Airplanes fly at over 800 kilometers per hour, thousands of them in the sky at the same time, and somehow they almost never collide. Not because the sky is empty, and not because pilots can simply see each other. In reality, most of the time, they can't. At cruising altitude, visibility is limited, distances are massive, and speeds are too high for human reaction alone to make a difference. Yet every day, thousands of flights take off, cross paths, change altitude, and land safely without ever coming close to disaster. So what's actually preventing collisions? Because if you remove the system behind it, the sky wouldn't look organized. It would look like chaos. And the truth is, there is an invisible structure controlling everything. Every movement, every altitude, every direction. A system so precise that even a small mistake could have catastrophic consequences. Most people assume pilots are responsible for avoiding collisions. It makes sense. They're trained, experienced, and constantly monitoring their surroundings. But that assumption is completely wrong. Pilots are not the ones managing the bigger picture. From inside the cockpit, a pilot can only see a limited portion of the sky. Even with advanced instruments, they don't have full awareness of every aircraft nearby. And when you consider that planes are moving at extreme speeds, visual avoidance becomes almost impossible. So if pilots aren't controlling the system, then who is? Because clearly, something is coordinating thousands of aircraft at the same time, making sure they don't interfere with each other. The real control happens on the ground. Inside highly coordinated centers, air traffic controllers monitor the sky in real time. They don't see airplanes directly. Instead, they see data, positions, speeds, altitudes, all updated constantly. Each aircraft becomes a moving point in a massive system, and controllers are responsible for ensuring that none of those points ever get too close to each other. This isn't a passive system. It requires constant attention, continuous adjustments, and precise communication. But here's what makes it even more complex. Controllers are not managing one or two planes. They are managing dozens at the same time, sometimes even more, all moving in different directions, at different speeds, and at different altitudes. So how do they actually see all of this? The answer is radar. Radar systems constantly scan the sky, sending signals that bounce off aircraft and return with information about their position. But modern systems go even further. Aircraft transmit their own data, including altitude, identification, and speed. This creates a highly accurate picture of what's happening in the airspace. Instead of guessing, controllers know exactly where every aircraft is. And more importantly, they know where each one is going. Because tracking the present is not enough. The system has to predict the future. This is where the most important concept comes in: separation. Planes are never allowed to get too close to each other. There are strict minimum distances that must always be maintained. Horizontally, aircraft must be separated by several kilometers. Vertically, they must maintain at least 1,000 feet of altitude difference in most cases. These invisible buffers create space between every aircraft, and that space is what prevents collisions. Not last-second reactions, not emergency maneuvers, but constant, controlled distance. The system is designed so that planes are never even close to colliding in the first place. But separation alone isn't enough. The sky is also organized into layers. Aircraft flying in opposite directions are assigned different altitudes. This creates invisible lanes in the sky, similar to highways. For example, planes flying in one direction might use even-numbered altitudes, while those flying in the opposite direction use odd-numbered ones. This simple rule dramatically reduces the chances of conflict. So instead of random movement, the sky becomes structured. Every aircraft follows a specific path at a specific altitude within a controlled system. None of this would work without communication. Air traffic controllers are constantly talking to pilots, giving instructions, adjusting routes, and maintaining separation. Pilots don't make independent decisions about where to go. They follow instructions. Every altitude change, every turn, every descent is coordinated. And this communication has to be precise. there is no room for misunderstanding. Even small errors in communication can create dangerous situations. But even with all of this, there is still a backup system, something designed for the worst-case scenario. It's called TCAS, Traffic Collision Avoidance System. TCAS works directly between aircraft. It monitors nearby planes and calculates potential collision risks independently from air traffic control. If two aircraft get too close, TCAS issues immediate instructions to the pilots. One plane is told to climb, the other to descend. These instructions are automatic and must be followed immediately. This means that even if communication fails, even if controllers make a mistake, there is still a final layer of protection. Because the reality is, the system is not perfect. There are moments where planes come closer than they should. There are communication errors, delays, unexpected situations. Weather can force aircraft into tighter spaces. Traffic congestion can increase pressure on controllers. Human fatigue can become a factor, but the system is built with multiple layers of protection. If one part fails, another takes over. It's not about avoiding all mistakes. It's about preventing those mistakes from becoming disasters. So the reason planes don't collide isn't luck. It's not visibility. It's not even just skill. It's a highly structured system built on prediction, coordination, and constant control. Every aircraft is tracked. Every movement is planned. Every risk is managed before it becomes a problem. And the next time you look up and see a plane crossing the sky, remember this: it's not flying freely. It's part of a system you can't see, a system that is constantly working to make sure that thousands of aircraft move safely through the same space without ever colliding. But there's another layer most people never think about. The sky isn't controlled as a single space. It's divided into sectors. Each sector is managed by different air traffic controllers, each responsible for a specific portion of airspace. As an aircraft moves across the country, it doesn't stay with the same controller. It gets handed off from one sector to another. Each controller takes responsibility for that aircraft during its time in that zone, ensuring separation and coordination. This system prevents overload. No single controller is responsible for too many aircraft at once. Instead, responsibility is distributed, creating a structured flow across the entire airspace. It's like a relay system, where control is constantly transferred without interrupting the flight. And here's the most important part of all. Air traffic control isn't just reacting to where planes are, it's constantly predicting where they will be. Every movement, every trajectory, every change in speed is calculated in advance. Controllers don't wait for planes to get close. They see potential conflicts minutes ahead of time. That allows them to make small adjustments early, long before anything becomes dangerous. A slight altitude change, a minor route correction. This is what truly prevents collisions. Not last-second decisions, but early prediction. The system is designed so that problems are solved before they even exist. And that's why, despite the complexity, despite the scale, despite the constant movement, the sky remains one of the safest transportation systems in the world. Because planes don't avoid collisions. They prevent them before they ever have the chance to happen.